Hi, welcome to the next video for the acids and bases topic for Year 11 Chemistry. This is the fourth video. We're still in subtopic 5.3. So in the last one we had a look through the pH scale, and we also had a look at how you calculate pH and indicators. Now we're going to be moving on to acid rain. So all rainwater is naturally acidic. So when you're thinking about acid rain, you might think about this sort of thing with groundskeeper Willie that's happening here in The Simpsons, and you think that acid rain is something that falls from the sky that's really bad and it's going to dissolve clothing, burn skin, all those sorts of things. That's not the reality of acid rain. But all rain is naturally acidic because you have dissolved carbon dioxide. So carbon dioxide is a acidic oxide. So we've had a look at acidic oxides a couple of videos ago. Because it's a non-metal oxide, when it dissolves in water, it forms a acid. Okay. However, it forms an organic acid, which is a weak acid. So here's the equation here. And what happens is that when carbon dioxide dissolves in water, it forms carbonic acid. Weak acid, so it doesn't donate a lot of H plus to the water, so the pH is only slightly below 7. So what we talk about when we're talking about acid rain is we're talking about rain with a pH below 5.6. So that's a really important definition for you to know. So pollution from industry often contains oxides of nitrogen and sulfur. So when we burn fuels or fossil fuels, often that has quite a lot of sulfur in it. Okay, and that can be released to the atmosphere. And particularly here in Australia, a lot of our fuels that we get from the ground, like coal, has a lot of sulfur content in it. So we can release a lot of sulfur dioxide to the atmosphere. When we've got oxides of nitrogen as well, now nitrogen has a triple bond, triple bond N, but when we've got high temperatures or high energy, such as you would get from a burning fossil fuels, you combine that nitrogen with oxygen in the air to form oxides of nitrogen. And so what we call oxides of nitrogen are NOxes, and what we call oxides of sulfur are SOxes. So there's NO2, NO, there's a couple of different oxides of nitrogen, and there's SO2, SO3 for sulfur as well. So we get these dissolving in water, and there's two equations for the formation of acids containing nitrogen. So there's this one here of nitrogen dioxide forming nitric acid and nitrous acid, or just this reaction here forming nitric acid and nitrogen monoxide. What we've got here is sulfur dioxide and sulfur trioxide, both forming acids, sulfurous acid and sulfuric acid. Now the characteristics of these and why they are different from the carbonic acid is that these are mineral acids, which means they're strong acids. They readily donate protons, which means they're going to lower the pH far more consistently than a carbonic acid will. So the main sources of NOxes and SOxes, so you can see here, just grab this from some of the areas. This is actually around Europe, and I'm going to specifically look at Europe in a minute, and I'll show you why. But you can see that for oxides of nitrogen, a large portion of it here comes from road transport. So the high energy of the combustion engine in a car provides that energy needed to break that nitrogen triple bond to form oxides of nitrogen. If we're looking at sulfur, you can see the major cause of sulfur is energy production and distribution. So those burning of those fossil fuels that have the sulfur in them, they're going to release lots of oxides of nitrogen as well. Of sulfur, I should say. Now, acid rain usually becomes a problem where we have what we call high population density. So when you have a large amount of people in a small area, you get a lot of pollution, and that's where you can lead to acid rain. So Europe, in particular, has a very high density. Lots of countries, lots of people, far more densely populated than Australia, for example, where all of our citizens are kind of populated around the coast, and the cities aren't really close together. So lots of people, small area for Europe, lots of pollution, means that we're going to have a lot of acid rain. Now, one of the main issues for acid rain is the fact that because it's a gas particle, it can be carried on the wind, which means that pollution from one country may cause acid rain in another country. So if we look at Europe here, what we've got here is a graph showing acid rain issues in Europe. Now, the biggest polluters in Europe, okay, are the United Kingdom and Germany, if we're looking at the amount of pollution that's given out per country, okay? So what happens here, though, is the wind currents from the United Kingdom. You can see here we've got a medium risk of acid rain, but they're the heaviest polluter. They don't have the biggest issue of acid rain. We've actually got air currents that carry the pollution over this way here from Germany and the United K, and you actually get into here, Eastern Europe is where you get the biggest issue of acid rain. Even up here into Sweden and Finland as well, they don't do a lot of pollution. They're actually quite clean countries using a lot of renewable sources of energy. But because you've got a lot of, you've got the Swiss Alps through here, you've got a lot of mountains, the pollution comes through there, and then what happens is because of the mountains, it causes it to precipitate down with rain, and you get acid rain. So acid rain is a problem that Europe in particular is really having to face, because it's something that where the pollution in one country affects another. So there's a lot of communication and collaboration between scientists, that key concept there, communication and collaboration, that's going to be really important for tackling this problem that crosses borders. Okay, so there's a lot of money being put into tackling acid rain. They do things like try to remove the gases before they're produced into the atmosphere. We use things in factories called scrubbers, which helps to capture the oxides of nitrogen and sulfur before they can go into the atmosphere. And that's really important in terms of reducing the amount of acid rain. And it's something that the European Union as a whole will need to collaborate around if they're going to overcome this problem. Now, some of the environmental consequences of acid rain. Because acid rain contains strong acids, they readily donate protons to waterways, and the increased H+ in the waterways can lead to a number of different problems. So the real main environmental problems, there's two main environmental problems, is acidification of lakes. Fish are very susceptible to changes in pH. They're very sensitive. So if you've ever had a fish tank at home, you'll know that you might you have to be taking very good care of the pH. If you've ever had goldfish where their tail fins or their side fins start to kind of like rot or decay, that's normally a pH issue. So you need to keep it very, very carefully monitored and at the right pH. So if you acidify lakes, you can get to the point where it's uninhabitable for marine and plant life, which is quite bad, because sometimes obviously those lakes are relied upon for food, fragile ecosystems, so impacting something like a lake has a very big flow-on effect. It can also be really damaging for forests, so particularly through Scandinavia, through Europe, there's been lots of issues with forests being damaged by acid rain. So the acid rain doesn't like burn the trees or anything like that, like you might think of that we see in the movies. What actually happens is that the rain hits the soil, and the soil which contains aluminosilicates, so something that contains aluminium in it, that aluminium gets what's called leached or released by the acid rain. Such large quantities of it actually are poisonous to the forest, so they start to die. So that's a big issue as well. One of the other issues for Europe, you can see here in this picture, is that also limestone, which is calcium carbonate, reacts with the acid that falls down, and it starts to dissolve it. Not an environmental issue, but generally a very big cultural consideration, because places like Europe have massive history. A lot of their structures are made from marble, which was very readily available in the European continent, and so it's destroying that heritage, that culture for them. So they really need to make sure they're being careful around that. So that's just acid rain in a nutshell. There was back on one of the previous slides here a video which I've put together which goes into acid rain a little bit more. I suggest you have a look at that if you want to. But that's the end of subtopic 5.3. We're going to be starting to go into titrations in the next one. Alright, thanks guys, as always. Thank you, really appreciate you watching these, taking the time out to watch this. If you haven't, please hit subscribe, and if you've got any comments or videos you'd like me to do, just leave them down below. Thanks guys.